We're now going to consider our algebraic methods for solving systems of linear equations. The first method we will look at is the substitution method. Here's an example. We have the system x equals 2y and 3x minus 4y equals 6. This system is nicely set up for substitution because the idea behind substitution is that we want to take our two equations with two variables and somehow do a substitution so that one of the variables disappears and we end up with a single equation in one variable. Then we can solve that equation using our previously established algebraic methods. So, what we see in this first equation is this equation is already solved for x. We have x is equal to something that only involves y. So, what we can do then is take this expression, the expression that we get equal to x, and substitute it into our second equation where we see x. So our second equation will become 3 times x, but now x, we are substituting 2y in its place because x is equal to 2y. The rest of the equation will remain unchanged. So now we have this one equation with one variable, and we can solve it. 3 times 2 is 6. Combining like terms, we have 2y equals 6. And dividing by 2 on each side, we get y equals 3. Great, so we have a part of a solution, but remember a complete solution is both an x value and a y value. So how are we going to get the x value? We can do a second substitution. We take this value we've just found for y and substitute it back into this equation for x. Really, we could substitute it into either of these equations. It doesn't matter which one. We would then solve that equation for x to find its value. It's just that this equation, since it's already solved for x, will be easier to deal with. So that equation will become x equals 2 times y. And y, we know, is 3. So we'll substitute 3 in for y. And we get x equals 6. So the solution is the point 6, 3. Here's an overview of what we just did. The first thing we need to do when using substitution is to solve one equation for one variable. In this example, that was already done for us. We'll see an example next in which we need to do that. The second step was to substitute into the other equation using the expression we found in step 1. Once we've done that, there will only be one equation with one variable. So the third step then is to solve that new equation in one variable. Once we get that value, then we're halfway to our solution. We only need the other number, and to get that, step 4 would be substitute that value into one of the equations to find the value of the other variable. That will give us the complete solution. Here's one more example of the substitution method. This is the system that we saw at the beginning. We verified that 4, -1 was a solution, but now we're going to see how we can find that using the substitution method. What we need to do to start is we're going to have to solve one of these two equations for either x or y. Now, it will work out the same no matter which one we choose. We can choose to solve the first equation for x, the first equation for y, the second equation for x, or the second equation for y. However, there is one that will be easier than the others in this case, and it is to solve the second equation for y. And the reason that that one will be easier is because look at the coefficient. When we're solving this equation for y, all we have to do is get rid of this -1. In all three of these others, we would have to divide by a 2 or a 3, and we would end up with some crazy looking fractions. But here, that's not going to happen. So let's solve this equation for y. We're going to get negative y equals negative 3x plus 13 when we subtract 3x from both sides, and then multiplying through by a negative 1, we get y equals positive 3x minus 13. Now we have an equation solved for a variable. We can go ahead and substitute into our other equation. Notice that this is solved for y, so we must substitute this expression into the other equation where we see y. So that equation is going to become 2x plus 3y. But again, we're replacing y now with this 3x minus 13 equals 5. And our y has vanished. We have one equation with one variable, x. So we solve that equation. Distribute the 3. Combine like terms, 11x minus 39 equals 5. Collect our constants together. And finally divide by the coefficient of x. We get x equals 4. We still need to get y, so we're going to resubstitute our x value into this equation. Either of these will also work, but this one will give us the answer faster because we already have solved it for y. These ones we would have to solve for y again. And so this equation is going to become y equals 3x minus 13, but x is 4. And so we get y equals 12 minus 13, y equals 1. And so our solution then is the point 4, 12 minus 13 of course is negative 1. So our solution is the point 4, negative 1, just as we found or verified earlier. The final method we're going to discuss is our second algebraic method called the elimination method. And here's an example to demonstrate that. We've seen this system before too. We solved this system graphically. We found that the solution was 5, 3. Let's see another way to get that, an algebraic method. Notice the way this is set up, that in this equation I have a positive 5y, and in this equation I have a negative 5y. Well, what happens if I were to add the equations? That is to say, I add the x terms, I add the y terms, and I add the constant terms. Well, x plus 3x gives me 4x. 5y minus 5y just gives me 0. And 20 plus 0 gives me 20. Look at that. I get an equation that has only x. Y has vanished. And I don't really need that plus 0. This is 4x equals 20. And this is easy to solve. Just divide by that coefficient. We get x equals 5. So the idea behind the elimination method is we're going to add the equations together. And what that accomplishes, it eliminates one of the variables for us. Of course, we have to get the other variable value. And we do that by substitution, just as in the substitution method. And so we're going to take this and substitute it into either one of these equations. I'm just going to pick the top one. And so what we get is that x plus 5y equals 20 becomes 5 plus 5y equals 20. And we solve this for y. So subtract 5 from both sides. 5y equals 15. Divide both sides by 5. We get that y equals 3. And so our solution is the point 5, 3. This was the same solution that we arrived at using the graphical method. Here's an explanation of what we just did in steps. The first step for the elimination method is going to be to set up the equations so that they are in a suitable form for elimination. Again, in this example, this was already done for us. It was set up so that the y's would be eliminated as soon as we added the equations. We'll see an example next where we have to do the setting up ourselves. The next step is, once the equations are set up for elimination, is to do the elimination by adding the equations term by term. Because of this, the elimination method is sometimes called the addition method. Once we do that, one variable has been eliminated, and so we get an equation, a new equation in one variable. So naturally, the third step is to solve that new equation. Finally, we take that value and we substitute it into one of our original equations, solve it, and we will have the value of the second variable. Here's one more example of the elimination method. If you observe, if we try to add the equations immediately, we're going to get a 6x minus 2y equals 18. A new equation, but one that has two variables. It's not going to eliminate a variable, and so we need to do something to set the system up for elimination before we add. Here's what we do. Remember that if we do the same thing to both sides of an equation, then we get an equivalent equation. That's what we're going to do. See, because if you notice, here we have a y, here we have a negative 3y. If this were a positive 3y, then we would be able to eliminate the y's. So let's do that. Let's multiply on both sides by 3. And so our second equation becomes 6x plus 3y equals 33. Our first equation we're going to leave alone. 4x minus 3y equals 7. Now, the equations have been set up for elimination. When we add, we'll have 10x, this will cancel to 0, equals 40. 10x equals 40. Dividing on both sides by 10, we get x equals 4. And we can substitute back into one of the other equations. 4x minus 3y equals 7 becomes 4 times 4 minus 3y equals 7. 16 minus 3y equals 7. Negative 3y equals 7 minus 16, which is negative 9. Dividing by negative 3, y equals 3. And so the solution we get is x equals 4, y equals 3. As a final note, we could have set the equations up to eliminate x instead of y by multiplying on both sides of the second equation by a negative 2, as shown here. Again, we get a solution of 4, 3,